So today I would like to talk about what is lattice energy. So basically lattice energy is it's basically a sort of energy that release that it releases it gets released it gets stated. This is a proper definition. The amount of energy that is released, amount of energy that is released when 1 mole of gaseous ion is formed from gaseous cation and anion. Or the amount of energy that is needed, amount of energy needed to break down 1 mole of iron to form gaseous cation and anion. So now, the amount of energy that is needed when 1 mole of a gaseous ion is formed in gaseous cation or gaseous cation, or amount of energy that is needed to break down 1 mole of iron to form gaseous cation and anion. So let's demonstrate an example as well. For example, Na, which is gaseous, chlorine, which is also gaseous, combines to form NaCl. So one gaseous cation combined with another gaseous anion to form the gaseous ion, which is NaCl. It's basically a gaseous ion, and then the energy that is released. Energy is known as lattice energy. Lattice energy. This energy is known as lattice energy. But if we talk about, this is basically lattice energy that is released when 1 mole of ionic compound. It's basically an ionic compound that is formed by the cation and anion, the formation of the cation and anion. So heat. Not talk about the heat of formation. This is basically heat of lattice. Not talk about the heat of formation. For example, if I would talk about, this is basically anion. N A solid plus chlorine gaseous 1/2 Cl2 gaseous is equals to NaCl. So remember one thing, this is entirely different. As you can see that one in gaseous state while other in solid state combined to form a compound. So when the 1 molar compound, the energy that is released or given when 1 mole of compound is formed by the breakdown the energy that is released or given no released when one molar compound is formed from element in stable state. Or take the state as a quantity, which is energy of the energy that is needed when one mole of a compound is break down. The energy that is needed when a compound to form the element, right? To form the element. So the amount of heat that is when mole of a compound is formed from its element in a pure and stable state. So that's the difference between heat of fusion, see the heat of formation is entirely different. One may include solid with other gases, but when we talk about the lattice energy, we only concerned with gaseous energy. Let's demonstrate how we can write it in a way clear. So let's go. Let's take an example of it. For example, this is an A. So first of all, I'm taking example of sodium and chlorine, and last I'll be writing sodium chloride. It's solid. So firstly, it changes into gaseous sodium. A G changes into gaseous sodium. Changes into gaseous sodium by heat of sublimation. By heat of sublimation, it changes into any gaseous by heat of sublimation. Right. So first of all, now the Na gaseous is changes into sodium ion by the ionization energy. Sublimation energy is basically negative because when you give it, it usually gets released, and something that releases negative. We talk about Na plus, like we will give the ionization energy here, and ionization energy, something like this. Ionization energy, ionization energy, something like this. No, ionization energy is given to it. Now it's sodium ion. Okay, right? It's just a sodium ion here, which is in gaseous state. First of all, solid the heat sublimation energy is given to sodium gaseous, then ionization energy is sodium cation. Right. If we talk about the other factor here, which is chlorine, 1 upon 2 Cl2, right? 1 upon 2 Cl2. The first thing we need is to dissociate it into single atom. So change it to Cl or Cl by bond dissociation energy. Bond dissociation energy. Bond dissociation energy. After the electron affinity, basically the energy is given the energy. The electron affinity increases the electron from sodium and gets a negative charge. And so now we are going to write the electron affinity, which is negative. The first is negative. Electron affinity, it's negative. Then what happens with it? The firstly chlorine changes to chlorine gas, we have given the bond energy, and then slices it to chlorine ion by gaining electron energy is released, right? So the final equation something like this. Something like this. And cheers. One upon two chlorine gaseous equals to NaCl, which is also gaseous in nature. NaCl, which is also gaseous in nature. So this is something about the ionization energy. Same step goes to for MgO, which is magnesium oxide as well. But they have the magnesium number, it has +2 charge, which means it has 2 ionization energies. But the higher ionization level, second, if we talk about oxygen, it is 2 minus, which means first electron affinity will be negative, the electron will be positive just because of the effective nuclear charge, which means that during just because of the electron will not allow the electron to enter easily into it. However, it gains the first electron very easily, or second electron might face this is difficulty to again, like the factor. And the talking about the factors now.